Hello, good afternoon. I hope I am audible enough for you. Am I audible, dear friends? Okay, thank you. Sorry for the delay. There was some issue regarding the GoToWebinar app, and I was unable to log in and start the things. The first poll question, which is being answered, only 70% of the students have so far voted. So that has to do with your understanding of the vapor dome, which I discussed yesterday. Uh, this is about the comparison of the specific volume of dry saturated steam and that of saturated water. So if you are clear about, in the yesterday's class, I tried to explain you what is saturated water and what is dry saturated steam. So if you are clear about this concept of what do you understand by dry saturated steam, then I feel that this question is pretty simple. Okay. In spite of the fact that the question is pretty simple, I find that only 40% of about 40% of the students have answered it wrong. Okay, so far 75% of the students have voted, and of them 40% have got it wrong. Okay, so let me just explain you what is saturated liquid and what is saturated water and what is dry saturated steam. If you remember the discussion which we had when I talked about the heating of water at a constant pressure, so you must have realized that the water which is about to boil is called as saturated water. Then, if you heat it further, the saturated water, uh, it will uh, it will start the phase conversion. That is, the saturated water would start getting converted to steam, and finally that steam, if you heat it further, so that steam, when it becomes dry saturated, if you heat it further, it becomes superheated steam. Okay, and you know that when you talk about conversion of this, you have studied in physics 7th standard, that if you talk about conversion of water to steam, obviously you all understand that obviously it is a case of increase in specific volume. Okay, and so the question was pretty simple, and let me close this question and let me show you the results. So you see that what you see is 38% of the students have answered it wrong. Okay, the correct answer is true. Okay, that the specific volume of dry saturated steam is greater than that of saturated water. Okay, right? Specific volume of dry saturated steam is greater than that of saturated water. That is a correct answer. Uh, Now to the second question. Let me hide this and go to the second question. Again, this is to test your understanding of what we discussed yesterday. Okay, again, I find that substantial number of students are confused. We talked about subcooled water and we talked about saturated water. Okay, I told you that if you are talking about subcooled or subsaturated water, it has to do with the relation of that water with the boiling point. Okay, so if the boiling point is not reached when you are heating the water, that water is called as subcooled water. So, for example, electric heater, right, in the surroundings, under ambient pressure, then that water, though in the layman's language we call it as warm water when it starts heating and before it reaches the boiling point, but in the technical term from the thermodynamic perspective, you have a different name for that, and that water would be called as subcooled water. Okay, so subcooled or subsaturated water means the water whose temperature is lower than the saturated water, right? Because saturated water would be at the boiling point, a corresponding boiling point, saturation temperature. So the answer is obviously the temperature of subcooled water is greater than saturated water. That is a wrong statement. That is a wrong statement. And I find that 56% of the students have answered it correctly. Okay. So let me share the result. So the answer is temperature of subcooled water is greater than saturated water is false. Okay. So 44% of the students have answered it incorrectly and 56% of the class has followed this concept, right? So we understand it very carefully that when you talk about subcooled water means the water whose temperature is lower than the saturation temperature. I hope it is clear to you. Okay, let me hide this and let me talk about the next question. Now this is about the dryness fraction concept which we discussed yesterday. Okay. So if you remember our discussion which we had about the dryness fraction, I told you that the dryness fraction ranges from 0 to 1. Okay, the dryness fraction ranges from 0 to 1. And the dryness fraction concept talks about how dry the steam is, right? It talks about how dry the steam is. So obviously, when you are saying that it is a dry saturated steam, it is a dry saturated steam, and if you are comparing it with saturated liquid, then the saturated liquid would obviously will be 0% dry, and when you are talking about dry saturated liquid, it will be completely dry. Okay, so dry saturated steam is completely dry, whereas saturated liquid is not at all dry. Okay, so correct answer is, and let me just, only 50% of the students have voted, so I want others also to vote fast. So let me close this poll and let me share the results with you. So the results are with you now. I'm sharing the results. So the correct answer is unity. Okay, the dryness fraction of the steam, dry saturated steam, is unity. It is 1. Okay, 52% of the students have answered it correctly. 44% of the students have got it 48% of the students have got it completely wrong. Okay, so please note that when you talk about dry saturated steam, the dryness fraction is 1. If you talk about saturated liquid, that is the dryness fraction is 0. And anything in between, that is between saturated liquid, that is saturated water, and dry saturated steam, the dryness fraction would take a value between 0 and 1. Between 0 and 1. If it is more dry, closer to 1. If it is less dry, it would have a value closer to 0. If it is completely liquid, then its value is 0. Right? So just you need to register this in your mind. I hope it is clear to you. Right? So let me hide this also now. Let me go to the question, which is very interesting question. That is what I feel. It is an interesting question. So let us see what how we are going to answer this. All these questions which I have framed, okay, this is to test your understanding, the rigor with which you have understood the conceptual discussion which we had in the last 2 lectures on steam. I want all of the entire class to vote. I want the entire class to vote on this question. So only 66% of the students have voted. And let me close this poll. What is the question asked? The question asked is the temperature of wet steam. Now, when we talk about the steam, any steam, okay, so when would the water start converting to steam? The water would start converting to steam once the water reaches its saturation temperature. This you should be very clear about. When does the water start converting to steam? Okay, the water starts converting to steam when the water achieves the saturation temperature. In other words, when the water reaches its boiling point, it starts getting converted to steam. So at any stage when you have the steam between the saturated liquid to dry saturated steam phase, okay, the temperature would be equal to saturation temperature. Please be sure that when you are talking about wet steam or dry saturated steam or even saturated liquid, dry saturated steam and wet steam, all of them are at an equal temperature. Why is that so? That is because during phase transformation, the temperature does not change. Okay. So the temperature of saturated water, wet steam, and dry saturated steam are all equal, and that temperature is obviously equal to saturation temperature. Okay. So only 30% of the students, 30% of the students have got this right. And let me show you this result. So as you see on the board, the temperature of the wet steam, okay, the correct answer is temperature of the wet steam is equal to saturation temperature. Students who have answered it as less than saturation temperature or greater than saturation temperature, they are wrong. Okay, so please now, because from the poll result it appears that only about 70% of the class, okay, has got this wrong, right? That is because they have not listened to the discussion which we had using the vapor dome. Okay, so you should be very clear about what we were discussing on the vapor dome. That discussion would internalize you, that would explain you, okay, and you will never forget in your life this concept which I'm telling you. Okay, so if you listen to this concept with reference to the dome, then it would not be a confusing thing. Otherwise, you might feel it a bit confusing, right? So note that the correct answer is the wet steam is at saturation temperature. Even if I had asked you what is the temperature of saturated liquid, it is the same, that it is also equal to saturation temperature. If it is a dry saturated steam, still the answer continues to be the same. That is, it is equal to the saturation temperature. Okay. And the final question on this, let me hide this. And now let me move to the final question. Now let us see what you answer. So the correct answer for this is degree of superheat. Okay, if you remember our discussion which we are having yesterday, I told you that what is superheated steam is. I told you that superheated steam is the steam whose temperature is greater than the saturation temperature. Okay. Now, how much is the steam superheated? By how much temperature is the steam superheated? That is called as a degree of superheat. Okay. For example, when you talk about water, which is at atmospheric pressure, then the water which is at atmospheric pressure would have a saturation temperature of 100 degrees centigrade. Okay. And if you heat that water which is at atmospheric pressure, let us say which is at 25 degrees centigrade, it will continue heating, its temperature would continue rising. Okay, the temperature would rise up to 100 degrees centigrade, because if it's atmospheric pressure, then if you heat it further, the water would convert itself to dry saturated steam finally. And when it is dry saturated steam at 100 degrees centigrade, if you heat it further, it would become superheated. Right. Now, by how much degrees it gets superheated is nothing but what is the temperature difference finally of that steam, and what is the temperature of at which the water starts boiling, right? So in our case, now in this example which I had given you, I had talked about the atmospheric pressure. So obviously the saturation temperature at atmospheric pressure is 100 degrees centigrade, and what it means is that this water which has reached 100 degrees centigrade and has started boiling finally gets converted to steam at 100 degrees centigrade, and this water is continued heating up to 105 degrees centigrade, and when it reaches 105 degrees centigrade, you have stopped heating. So what it means is that this water has reached a temperature of 105, whereas the boiling point was 100 degrees centigrade. That is the difference between the temperature of the steam and the boiling point is 5 degrees centigrade, and that is called as the degree of superheat. Okay, so those who are confusing the degree of superheat concept with the boiling point, and let me close this poll and show you what how you are confused. Okay, so you see here I'm sharing this poll. So what is seen is, uh, some students assume that the temperature of the steam is itself degree of superheat. This 42% of the students, they feel that the temperature of the steam itself is degree of superheat. That is not correct. Steam is at 105 degrees centigrade. Others, that is 33%, feel that the boiling point is the degree of superheat. That is also not correct. 100 degrees centigrade is the boiling point at atmospheric pressure. But you are saying that degree of superheat is 100 degrees centigrade is incorrect. What is degree of superheat? It is the difference between the superheated steam temperature and its corresponding boiling point. So in this case, the superheated steam temperature is 105 and the corresponding boiling point at atmospheric pressure is 100. Hence, the degree of superheat is 105 minus 100, which is 5. So about 25% of the class, okay, have understood this concept of degree of superheat. Okay, though I had not discussed what is degree of superheat in the last lecture, but I thought that you might reflect on this concept, okay, and figure out what exactly is that degree of superheat talking about. Okay, so 25% of the students have answered this correctly. Okay, so that is good enough, right? So I have completed the poll questions, and let me start with the discussion. Okay. I will just go to the, if you see the whiteboard, I will share the whiteboard with you first. Let me make sure that you are in a position to see the whiteboard. Okay, so the whiteboard is seen now, and I am now to revise the concept, okay, of the vapor dome, I mean to say. Okay, so let me choose a color here. Allow me some time to just, okay. I'm choosing a red. Okay, and let me draw this now. Okay, so sorry. What I am going to draw is the vapor dome once again. Okay, and I will be explaining you. So let me draw this now. Yeah. There's some problem with the orientation. I'm not getting it. Why is that happening? Just let me clear it again. Okay. So this is the vapor dome. This is the vapor dome. Let us say that this is temperature, and instead of enthalpy, I'll take specific volume. V is the specific volume. Specific volume. And this is the critical point. This line is called as saturated liquid line. This is called as dry saturated steam line. Dry saturated steam line, or simply gas line. Okay. And this region within this is the wet steam region. Wet steam region. Okay. Now suppose you talk about heating the water. Okay. Heating the water at constant pressure. Suppose this is a constant, sorry, this is horizontal, azimuth is horizontal. So suppose this is a constant pressure heating line. Okay, constant pressure heating line. Then I told you that this point, if I call it as A, and this is B, and this is C, then point A, that is VA, will be the specific volume of saturated water. Okay, and VB will be specific volume of dry saturated steam. Dry saturated steam. Okay. So if you look at this, the first poll question was about comparing the steam volume with the liquid volume. Okay. So this VA is VF. Okay. VF means water, F for water. Okay. And VG is G for gas. Right. So VG is much greater actually. VG is much greater than VF. Okay, so I want you to tell me the value of VF from the steam table at 1 atmospheric pressure, 1.013 bar. And I want you to tell me the value of VG at 1.013 bar. So please write that value in the questions column. Tell me the value of specific volume at 1.013 bar and VG value at 1.013 bar. From the steam tables, tell me this value. Okay. Okay, so Sharvari is giving me some answer. Kunal is giving me some answer. What is the unit of that, Kunal? And Gunjan, what unit you are expecting? So you see that Kunal and Sharvari, okay, you'll find that it is in the order of 0.001. Yeah, correct. The unit is meter cube per kg. So Gunjan, if you are using a steam table, you see that in your steam table might be that it is written into 10 raised to minus 3 in the column at the top of VF and VG, where your VF and VG notations are there, Gunjan, in the steam table which you are using, you will find that it is 10 raised to minus 3 which is given. Okay, so your answer should be, Gunjan, 1.04 into 10 raised to minus 3 and 1694 into 10 raised to minus 3. Okay, so that correction you have to make, right? So it means that uh, the specific volume of liquid, or that is saturated water, is about, it's very less. You see it. How many times is it less? VF is 0.001, right? And VJ is about 1.67. So you see that when there is a phase transformation, there is a tremendous increase in the specific volume, right? So there is a tremendous expansion. So when there is a phase transformation, there is a tremendous increase in the specific volume on the order, and you can see the order by how many times this is increasing. Okay, so VF is around 0.001 and VG is around 1.67, like this. Okay, so that you have to appreciate that this is what is happening when you are having a conversion, right? Now suppose you are given that it is a wet steam which is 50% dry, which is a wet steam 50% dry. So you find out the specific volume of that wet steam. Similar to what we had done for enthalpy, I want you to do the same trick for finding the specific volume of wet steam. So Kunal, Sharvari, Gunjan. So what we'll have to do is that for finding the specific volume of wet steam, right, what you should do is V wet will be Vf plus x times of Vg minus Vf, where x is the dryness fraction, and when I'm saying it is 50% wet or 50% dry, x is 0.5. Okay, so Vf is around 0.001, Vg is around 1.673, and dryness fraction is 0.3. So this will give you the specific volume. This will give you the specific volume of the wet steam. Wet steam. Okay. I hope it is clear to you how to find the specific volume. Tell me the answers. Gunjan, Kunal, Sharvari, Yashraj, Ankush. So what is the answers? What are the answers you are getting? Okay. Answers, I want your answers. I want the answer of specific volume of wet steam which is 50% dry, which is 50% dry. Okay. Sharvari is given me the answer as 0.837. Others can also attempt. 50% dry. How to find that? Vf plus x times of Vg minus Vf. Vf plus x times of Vg minus Vf should give you the specific volume of wet steam. Apart from Sharvari, okay, Kunal has also given it right. Kunal, Sharvari. And what would be the unit of this? The unit of this would be meter cube per kg because it is a specific volume. Okay, so the unit of it is meter cube per kg. Meter cube per kg. Jay, yeah, it's correct, Jay. Just check whether it is 873 or 837. Yeah, correct, Jay. So Gunjan, Jay, Sharwari, Kunal, they have given the answer. Maheshwari has also given it right. Okay, let us say that now the pressure is 10 bar. The steam is 80% dry. Steam is 80% dry. The pressure is 10 bar. I want you to find the specific volume. Okay, is the question clear? The steam is 80% dry. Okay, let me write down. Let me write down this. Steam is 80% dry. Okay, and the pressure is 10 bar. Okay, I want you to find the specific volume of wet steam. I want you to find the specific enthalpy of wet steam, and I also want you to find the specific entropy of wet steam. The relations are the same. Vf plus x times of Vg minus Vf. Enthalpy of wet steam would be Hf plus x times of Hg minus Hf, and this would be Sf plus x times of Sg minus Sf. Okay, so 80% dry means x is 0.8. So please tell me these answers. Use the steam tables and tell me these answers. Steam is 80% dry, the pressure is 10 bar. The absolute pressure of the steam is 10 bar. So Sharwari is getting me some answer. Neha has given some answer. I will have to check because Neha and Sharwari have two different answers. X has to be taken as 0.8. The pressure is 10 bar. Okay. So from the steam tables, what we'll have to do is that we'll have to read the value of Vf at 10 bar and Vg at 10 bar. X is to be taken as 0.8. Similarly, enthalpy of dry saturated steam at 10 bar and enthalpy of saturated liquid at 10 bar. Similarly, entropy of saturated liquid at 10 bar and entropy of dry saturated steam. Entropy of dry saturated steam at 10 bar. In all the cases, the X value is 0.8. In all the cases, the X value is 0.8. All the cases, the X value is 0.8. Okay. So Gunjan, Anamta, you just please check your answer, Anamta. Anamta, please check your answer. I feel that it is wrong. What is the VF value you have got, Anamta? VF value is what, Anamta? Yeah, Gunjan and Kunal, they are getting right answers. Neha, you also need to check your value of V weight. Neha. Yeah, Nikhil Pardeshi has also got it wrong, right? Neha and Anamta, please check your answers about specific volume. So Gunjan is getting the entropy value also. What is the unit of entropy, Gunjan? Yeah, Neha, you have got the specific enthalpy correct, but you need to check your specific volume, Neha. Your specific enthalpy value is right, but you need to check your specific volume. Sharvari, you are right. Anamta, please try. Yeah, your VF is correct, Anamta. What is the value of VG, Anamta? Find the value of VG, Anamta, then take the difference between VG and VF and then multiply that difference of VG and VF with zero 0.8 and add it back to VF. So that will give you the answer of V weight, Anamta. So please check that and redo the calculations. Others, they should also buy the steam tables. See, I am repeatedly telling you that very few students are in the possession of steam tables. Okay, so if you don't have the steam tables, then it would be very difficult for you to understand and also enjoy these lectures. Okay, correct, Kunal, your entropy value is correct. Sharvari has also got it right. So Sharvari, Gunjan, and Kunal have got the entropy values also. Where is Gargi is not seen nowadays. Where is Gargi? Sharvari, you are right. So just hurry up and tell me the answers. All right, assuming that very few students have the stream tables with them. Okay, so I'll take this as a representative answers. Yeah, Nikhil, you are right. So Nikhil, Sharvari, Kunal, Neha, Gunjan, Anamta has tried. She is trying, I guess. Okay, they have attempted this question, so I'm thankful to them. Okay, I want others also to. This is not a very difficult subject. Only thing is that you need to go step by step, and yeah, Neha, it is the correct answer. You need to go step by step, and you need to spend some time because that is there is no alternative to spending some time and getting the answer. Ananta, what you are getting? You are closer to the answer, Ananta, for enthalpy, but that is slightly off the mark. It should be around 2300. Okay, so just check where which stream tables you are using, Ananta. Are you using some online kind of stuff or a physical stream table? Which book, textbook you are using? Is it? Or you have purchased the stream tables? Acha. Yes, okay. All right. I don't feel that the answer, the table values would be wrong. Just check the units if there is some problem with the units, right? Otherwise, if you are following the same methodology of finding the value of Hg, Hf, okay, Hg minus Hf is Hfg, by the way, okay. You can straight away, if you don't want to do the subtraction of Hg and Hf, we can straight away use the value of latent heat of vaporization, which is nothing but Hfg. Okay, Hfg, right? So it is very simple. So if you want to find, now let us say that if it is a saturated liquid, then how will these calculations change? In terms of formula, what will happen? If it is a saturated liquid, then the X would be 0, right? And S weight would be SF. It means that it is no longer weight, it would be SF. Similarly, in your enthalpy expression, if you put saturated liquid X is equal to 0, you will get the enthalpy value as HF, right? If you put the value of X is equal to 0 in specific volume, what you will get? V is equal to VF, right? If you put X is equal to 1, what will happen in all these three expressions? If you put X is equal to 1, it means that your SF term would cancel in the entropy expression and you will get SG, right? If you put X is equal to 1 in the enthalpy expression, your HF term would cancel and you will get HG. And if you put X is equal to 1 in the specific volume expression, what you will get is VG. It means that if it is X is equal to 1, we are finding the enthalpy at the saturated region, dry saturated steam region. Okay. And if you are putting X is equal to 0, we are finding the enthalpy of saturated liquid. And if X takes the value between 0 and 1, then we are finding the enthalpy of wet steam, entropy of wet steam, specific volume of wet steam. Okay. So it is very simple that way, right? So the value of X would give you how dry the steam is. Okay, how dry the steam is. Okay, and in the next class, I would explain you that by using a apparatus called as separating and throttling calorimeter, one can determine the dryness fraction of the steam. Okay, so there is an apparatus. I'll just show you the figure today, and we will take the discussion in the next class. So just have a look at the figure of the separating and throttling calorimeter. In your practicals also you have that experiment to be performed. Hopefully the lockdown ends and we would be physically in a position to perform this experiment. Okay, so the diagram which you see in front of you, okay, right, that diagram is the diagram of separating and throttling calorimeter. Okay, that diagram is a separate device called as separating and throttling calorimeter. And though the term is called as calorimeter, it has nothing to do with the determination of calorific value. On the other hand, this separating and throttling calorimeter, which you see in front of you, it is a device for measuring the what? Anybody has the answer? Why is this device used? Can you tell me what is this device used for? I had already given you the answer before starting the lecture. Before starting this discussion, what is this device? What is this device called as? This device is called as, what is this device called as? Anybody from you? Nikhil, Kunal. This device is called as, yeah, Sharvari, separating and throttling calorimeter. Separating and throttling calorimeter. And this device is used for measuring the dryness fraction of the steam, that is the value of X. This device is called as separating and throttling calorimeter, and this device is used to measure the dryness fraction of the steam. Okay, so we would discuss this in much detail in the next class or maybe some other class. Okay, but for the time being, okay, I want all of you to purchase the steam table, okay, or use the physical steam table, whether it is available in some book or if you can purchase it from the market, it's good, right? And practice at least these points. What you should do is that you take different pressures, 10 bar, 50 bar, 100 bar, Okay, and use some random values of dryness fraction 1.1, 0.1, 0.2, 0.3, and calculate the enthalpy, entropy, and specific volume. Okay, so if you do such kind of calculations, that would give you the confidence of extracting the properties from the steam table. I have not yet taken the problems on superheated steam stuff. If the steam is superheated, how to do the calculations, that I have not yet explained to you. What I have explained to you is simply how to find the specific volume, how to find the specific enthalpy, and how to find the specific entropy if the steam is wet, if the steam is dry saturated, or if the steam is saturated liquid, if it is a saturated liquid. Okay, but if it is superheated steam, how to do that, that also we'll discuss, along with the fact that how to practically find the dryness fraction using a device called as separating and throttling calorimeter. Okay, so have a good day. Thanks for joining. Okay, and hope you have understood whatever has been explained to you in this class. Okay, thank you very much.